Hello, boys and girls. This is Mr. Mulaney, and I've been watching a lot of Joe Rogan's podcasts lately, so I stole his introduction. Graham Hancock and his theory on some advanced civilization way before we thought people were alive. Interesting stuff. So today we have a topic called converting units, also known as dimensional analysis or factor label method. I just think of it as converting units. A little conversation about it. This is, I'm sure, having taught this a while, the single most important skill you can learn to do well in chemistry and beyond, to do well in physics, to do well in any science using math, and this skill also will help you in the business world, as well as if you ever travel on vacation and you need to convert your dollars into whatever the local currency is. It's all this one skill, and it is something that you can probably already do to some extent. But what I want to do today is to formalize the process, because in the second semester of chemistry, like we'll use it some in the first semester, but we use it on pretty much every single test in the second semester. We're going to use this constantly. There's, in fact, in January, the test will essentially just be how to do these conversions. It'll be stuff you haven't seen yet, but it'll be how to do these conversions over and over again. So if you can do this, and if you can do this now, the rest of chemistry will be so much easier for you, I promise. And seriously, it's the one thing, if you just can dive in and learn now, it'll make chemistry twice as easy, I promise. So this is how to convert units. Yes. First thing you can see here is this is so easy. And you don't believe me, or maybe you do. How many weeks is it if you've got 14 days? Now, some of you can right away answer that in your head. You're converting from weeks to days. So what we have here is days and weeks are the units, and 14 is the number. So that's what we're doing, is we would be changing 14 days from the days unit into weeks. And there'd be a different number there. And 2 is the answer, right? Each week is 7 days. Right. So next, if you've got 4 quarters, how many dollars is that? So here you're converting from the quarters unit to the dollars unit. Now, even though the number is going to change from 4 quarters to $1, a key point here to be aware of up front is that even though you're changing from 4 quarters to $1, it's still the same amount of money. You can still buy the same amount of stuff with it. It's just changing the units, which is necessarily going to change the number associated with it. Like for length, if you measure in inches or if you measure in feet, it's 12 inches per foot. So something that is 3 feet long is going to be 36 inches long. So it's the same distance. It's just different units, so therefore different numbers. How many seconds are there in 2 minutes? So, or we can also turn this into a word problem. If you average 8 points per game, the season's 10 games long, how many points will you score in that season? So all of these are things that are pretty familiar, I think, to most of us, and pretty simple for you to do. But the point we're trying to make then, or the question is, so why am I watching this now? That's a fair question to ask at this point. And the reason for this, and the reason to talk about this and teach it now, is that in chemistry, you'll be asked, how many kPa are there in 1500 mmHg? In chemistry, we'd call that how many kilopascals are there in 1500 millimeters of mercury? Or you'll hit If you have 56 grams of carbon, then how many moles is that? And if you have 2 torr, then how many atmospheres is that? So that's what's going to be new. You're going to be hitting a bunch of chemistry units. And a lot of these terms, if not all of the units that you're going to be confronted with, are going to be brand new. So the goal here is to take the stuff you know, which is like minutes to hours or dollars and quarters and weeks and days, and look at the process that you do automatically with those, because honestly it's the exact same process that you'll be using for all of this chemistry stuff. And so if you can get that process formalized and comfortable with it, then later on, like these are all second semester formulas, except the first one. We'll talk in a minute. So this is second semester gas chemistry. So if you can convert in comfortably and know what you're doing to convert units, then when we hit the gas chemistry unit, you can just focus on the new stuff, the chemistry part of it, and know that this math portion is going to be, you know, same process. You can handle it, nothing to worry about, and so it'll give you a level of comfort and confidence that'll help you a lot. This here, grams to moles. We'll talk about this actually in about a month. So this will be the only one we'll use for conversions this first semester, but it is also extremely important. You will not be able to pass chemistry if you can't convert grams to moles and moles to grams. We'll talk more about that later. And then this is also gas chemistry. The second semester of chemistry is very, very math intensive. It is also a good precursor preparation for physics, which is also very math focused. So let's go forward. So let's take a look at 1 week equals, oh, I'm sorry, how did you know? We'll use the example, which is, let's say we did the one where we said that 14 days is how many weeks, or 2 weeks is how many days. I forget which way we did it. But in order to come up with the answer, you had to know this equivalency thing here. You had to have something that said this many of this unit is equal to this many of that unit. So that is a requirement. So you need to know what this is. Now in chemistry, what will happen is like that kilopascal one. Oh, I should look this up earlier, but I'm pretty darn sure it's 101.7 kilopascals, and that will be equal to 760 millimeters of mercury. So this is what will be given to you on the test. So you would then just use this equivalence rather to convert these units, rather than the exact same way you'd use weeks and days to convert. So you need to know, first of all, that 1 week is equal to 7 days. Now, with this knowledge of 1 week equals 7 days, you can create 2 fractions. So you can either, now there's math behind this, but why worry about the math? I just like to move things. It's just the way I am. So what I was kind of saying when I teach this, you'll see me do a lot of hand gestures. I do wax on, wax off. Basically, you can slide week above days, or you can slide days above weeks. So we'll create the 2 fractions. Here's the first one. We can take weeks and put it on top, and then we can take days and move it to the bottom. And we get this fraction here, 1 week over 7 days. Or we could do the wax off method, which is to put the days on top and week on the bottom. So week goes on the bottom, days goes on top, and we get this fraction. So we have 2 fractions now. And you can do this with any of them, like at that kilopascal millimeter mercury up here. If I find my mouse, there it is. Up here, you can put kilopascals on the bottom and millimeters of mercury up top. or vice versa, millimeters of mercury on the bottom and kilopascals on top. So we can always create two fractions as soon as we have this equivalence. Now, while both are mathematically valid, only one of them is ever useful to us. There's only one thing to remember in order to understand which fraction we want to use. The unit you start with always goes on the bottom. That's important. Now say that out loud. The unit you start with always goes on the bottom. Say it out loud. Say it. Say it! Say it! I love that clip. All right, so what does this mean? Let's put this into practice. So we have, our question was, if you have 14 days, how many weeks is that? Well, we know that 1 week is equal to 7 days, so from that we can come up with our two fractions. And as we just said out loud, the unit you start with always goes on the bottom. So we are going to pick the one, since we started with days, we're going to pick the one with days on the bottom. That would be this fraction that I've animated nicely. Thank you. So let's put that into effect. Oh, there it is. All right, so how do we set up a problem when we need to convert? First thing you always want to do, start by writing down what you were given to convert. In this case, it's 14 days. So you write down what you're given to convert. This could have been any number. This could have been 2.5 days. This could have been 3,728 days. That can be any number. 0.1 days. Next, after you've written down what you've been given to convert, you write down the fraction that we've created, the one we've chosen with the unit you start with on the bottom. Days. Now, we're going to do math. Okay. Yeah, let me teach that. So let's show you why, what happens, why we chose this as the useful fraction. Hopefully, in math, you were taught and you remember that if you ever come across something like 7 times a seventh equals, you can say, well, there's a 7 that's a numerator and a 7 that's a denominator, so they can just cancel each other out. So the answer is going to be 1, right? So basically, you were taught, hopefully, that when one thing is a numerator and the other is a denominator, they will cancel. And this is why we're going to take the unit we start with and put it on the bottom, because we're going to cancel the unit. Now, I'm canceling days. This does not get rid of the numbers. The numbers are still there. Okay? So all we've done is we've canceled days. So here's the math. What you're going to do, and I understand that some of you, many of you, most of you, I'm not sure how it's taught. Funny story. When I was in high school, I remember doing some homework, and that was a rare occasion, but I was doing some math homework because math always made me work, and I tried to get a little help from my dad, and he was an English teacher, but at the same time he was pretty smart. But he threw down the pencil and he said, I can't help you. This new math they're teaching you is completely different from what I was taught. I don't know what they're teaching you. I can't help you, sorry. And so I know you guys have been taught like the butterfly method or something, which is some sort of cross multiplication. I don't know anyway. The point is, that's not going to help you so much in science. You're going to have to learn this way of math, so I'll teach it to you now. It's pretty simple because science is set up with the math that I was taught, and it's how all the textbooks will be written. It's how all the videos online that will help you will be written. It's how scientists write and explain everything. So here's the math. hopefully you know this already. Some of you I know do not. But basically, we're not doing the butterfly method. What you will do for the math here is, first of all, find your mouse. There it is. You will take this number and you multiply it by the top number. So 14 times 1 is 14, right? Then you're going to take this number and you're going to divide it by the bottom number. So 14 divided by 7 equals 2. And if you put 2 as your answer and turn it into me, you're going to get it wrong. Because this is science. I've got a question for you. If you give me 1, I will give you 2. Does that sound like a fair deal? I'll do it. I'll do it tomorrow. If you give me $1, I will give you 2 pennies. See, so the unit matters. It matters a lot sometimes. So always, always, always write down your units, especially in science. So there's your answer. 2 weeks. Always write your unit down, please. Otherwise, I'll be just like that. So why do we write the unit? Hey, true story here. Mars probe lost a simple math error. So basically, you have NASA and the Jet Propulsion Laboratory. Big time scientists, super smart people. Someone got a little lazy. What happens was, and this is where units come into play as well. Now, I think you're all aware the United States is not on the metric system. Science has units, though, that are specific to science. In other words, in the late 1960s or so, all the scientists got together and they established these basic units, saying these are the official science units. And yes, Jet Propulsion Laboratory used the official science unit for force, which is the Newton. So for force, they put the number in newtons. And they sent that over to NASA. Well, for some reason, NASA doesn't or didn't use the official science unit. They did, I think it's either foot pounds, I know, weird unit, foot pounds, or just pounds. I'm not sure which one they used. But basically, different unit, different number. And so the Jet Propulsion Laboratory did their consulting work for NASA about the force required to get the orbiter around and sent it to NASA, and the units weren't tracked. So NASA took the number, thinking it was in foot pounds, and put that number into their calculations. And so here's Mars, the red planet, and this NASA orbiter was supposed to be a weather satellite orbiting Mars, and it went crashed into Mars. $125 million wasted, all because the units weren't canceled. Now, how would you like to be that guy, the person who is responsible for not tracking units, not canceling units, not paying attention to the basic math, and not only is it $25 million wasted, it's all the time and effort of everybody you work with. So you have to walk into work and they're all looking at you saying, everything I did for the past 2 years, you just tossed in the trash. So don't be that guy. Quick quiz. Finish this sentence. The unit you start with always goes, say it out loud. Say it. Say it.
Good answer. Good answer. I like the way you think. I'm going to be watching you.
All right. So So let's go over this again a little quicker, because sometimes when you do it very slowly, it kind of can tend to even be more confusing. So we've explained it once. We'll go through it a little faster. So real quick, process. Write down what you're converting. Write it down first, what you've been given. Take the equation that gives you how many of one unit equals how many of the other unit, 1 week equals 7 days, and turn that into a fraction with the unit you start with being put on the bottom. Then multiply what you're converting, what you've been given to convert, by this fraction. Pretty simple process. All right. So let's do an example. This time it will be I who writes it. There we go. All right. So let's do seconds to minutes. Okay. So do I have a calculator handy? I do. We can use a weird number then. All right. So my lucky number is 22. Write that down. 22 seconds. Question is, how many minutes is that? All right. So what we do, first thing we're going to do is, well, I guess you could say to ourselves, well, we know that 1 minute equals 60 seconds. We need this to answer the problem. So there it is. There, good. Step 1, write down what you're given to convert, 22 seconds. And write the unit down. Don't you dare not write the unit. Now we're going to multiply that by a fraction. I see I've got seconds here, so the unit I start with goes on the bottom. Then I'll say, well, here's seconds, here's minutes, so minutes goes on top. And then I look over here, there's a 1 in front of minutes, so I'll put the 1 there. 60 in front of seconds, so I put the 60 here. Seconds cancel seconds. Now I'm going to do 22 times 1 divided by 60. So I'm going to get my calculator out. 22 times 1 divided by 60 equals 0.0. Try that again. 0.366666666. Now, we'll get to the sig figs in a minute. I will do this. Call it 0.37. 0.37 minutes. That's the answer. It's 0.37 minutes. Let's do another example, because really that's as hard as it gets. And if you can do that, this is basically grams to moles. Exact same process. If you had 22 grams, and let's say that 1 gram was 60 moles, let's try that again. Let's say 60 grams is 1 mole. It's just a little sanity there. 60 grams is 1 mole. 22 grams, grams goes on the bottom, so this would be 60. Mole goes on top, 1 there, grams cancels grams, 22 times 1 divided by 60, 0.37 mole. Hey, there's one more thing I need to talk to you about. So notice I'm writing the unit down. Now what happens here is we canceled seconds, right? But notice minutes is not canceled. So this then carries over. And because it's not canceled, it doesn't disappear, so we have to kind of bring it along with us, and it becomes the new unit. Remember I talked about foot-pounds? That was this weird unit that was used by NASA. That's one where when you do the math, doing the math, both feet, which is what we'll call foot, and pounds, the numbers, these two different numbers are being multiplied by each other. And since they're not canceled, both of them have to carry over, and so we get this weird new unit called foot-pounds. Anyway, you just get used to it. It's just, if it's not canceled, you have to bring it over. So in this case, moles isn't canceled, so you bring it over, it becomes our new unit. Now, in our chemistry this year, we're not going to have a combined unit. But this isn't that hard either, though. You use these type of things all the time, a combined unit. If you went 60 miles and it was in 1 hour, how fast did you go? Well, I went 60 miles per hour. Miles over hours, miles per hour. So that's all miles per hour is is this math. So you're taking 60 miles. There's for some reason 1 hour is divided by it, whatever. You go 60 miles. And so you have miles on top, so it's going to be on top on this side of the equal sign, and hours on the bottom on this side of the equal sign. So this is where miles per hour comes from. It's just units that are not canceled carry over. No big deal. All right, let's clear this and do another example. This time again, no extraneous talking, so it gets easier. Boom. All right. What's another good example? Days, dollars, time. Let's do not do time. Let's do days. All right. 22 days, because 22 is my lucky number. If you have 22, let's do it the other way. If you have 22 weeks, how many days is that? All right. Try to do this on your own. Hit pause. Now, here, I'll give you one more thing. 1 week is 7 days. Remember, you need to know this. 1 week equals 7 days. All right. As soon as I finish with writing days, hit pause and do this yourself and see if you get it right. And I will assume that you have paused and calculated. Step 1. We're going to find my mouse. There it is. Write down what you're given to convert, which is 22 weeks. All right, so now we're going to multiply this by a fraction with the unit you start with, weeks, on the bottom. I'll just say WKS for weeks because I'm lazy. Days goes on top. And it's 7 days and 1 week, so week cancels weeks. So 22 times 7 divided by 1. Final answer, 22 times 7. 154, yeah, it is 154. If you write down 154 as your final answer, no, it's 154 days. All right, so pretty simple. This is honestly how you would convert millimeters of mercury to kilopascals, or anything to anything else, grams to moles, moles to grams. What I'd like to do though is take this one step up in difficulty, because we'll need it. Let's say, and I want to show you how useful this can be. Now, let's say that you have some number other than 22. Let's see what number pops into my head. 56, why not? 56 seconds. And the question is, how many years is that? So some of you may have been able to do stuff in your head, like, 4 quarters is $1, and boom, done in your head like that. But I don't know many people. In fact, I don't know anyone. Maybe I don't hang out with the right people, but I don't know anyone who can do this in their head just like that, right? So the exact same process we followed, though, can now take us to get this answer quickly and easily. Well, maybe not quickly, but easily. Just do one step at a time. Step 1. Here, let's do it this. Let me show you how we're going to approach this. We have nothing that equates seconds and years. We cannot go, whoops, wow. Well, that's fun. All right, seconds to years. We don't know what these numbers are, so we can't do it in one step. But we can go from seconds to minutes, and then we can go from minutes to hours, and then we can go from hours to days, and then we can go from days to years. So we have 1, 2, 3, 4 steps. We need to do 4 conversions to answer this question, but every conversion is just the same as the others. So first, start down by writing what you've been given to convert, 56 seconds. We know that there are 60 seconds. That's a 6, folks. 60 seconds in a minute. So the unit you start with always goes on the bottom. Seconds here, minutes here. 1 minute, 60 seconds. Cancel the seconds. This is whenever I say cancel your units, this is what we're saying to do. Now 56 divided by 60, calculator says 0.93. 0.93 minutes. Okay, now we're going to take this and do our second conversion. This is now what we're given to start with. 0. I always write the 0 first before a decimal point. It just helps me keep everything in place. I just find it reduces dumb mistakes, and that's been my life goal because I made a lot of dumb mistakes. Alrighty, 60 minutes, 1 hour. Alright, so minutes goes on the bottom, hour goes on top, 60, good. Now, minutes is canceled, so we're going to do 0.93 times 1 divided by 60. I kept the 0.9333333 on my calculator, so I didn't have to type that in. My answer is 0.015. We'll call it 0.016. And now it's hours. This becomes what we start with. So I'm going to write it here, 0.016 hours times hours on the bottom, days on top. There is 1 day is 24 hours. That'll be given over here if for real chemistry. In new units. Hours cancels. So now we can take 0.016 and divide it by 24. And we get, now, oh boy, it's too early to talk to you about scientific notation. So some of you may get this answer. If you have 6.48, look way in the right of your calculator display, and you will see a negative 04 here probably. This is called scientific notation, and what it really means is 6.48 times 10 to the negative 4. We'll talk about this in a month, but basically it means you're going to move the decimal point 4 points over. So it's 0, 1, 2, 3, 4. So the decimal point is 1, 2, 3, 4, 6, 4, 8. All right, we'll talk to that. Okay, days. D-A-Y. So 6.48 times 10 to the negative 4, or 0.00648 days. Take this number, 0.00648. Now your numbers might be a little bit off too, because if you rewrote it, as opposed to mine, which I'm just carrying it on, it has more decimal points along here. If you're within a decimal point or two of this, don't worry about it. It's not an error. It's just rounding. Times what? Ooh, I didn't write the unit down. See, this is actually what happens. A lot of times, you may have asked teachers this in the past before. Hey, do I multiply or divide? Right? So I got this. I didn't write the unit down, so I don't know what I'm multiplying by or dividing by. But by writing the unit down, you'll know what you need to multiply by, and you'll know what to need to divide by. So I messed up because I didn't write the unit down, so I didn't know where to go next on this fraction. I didn't know what to do. But by putting days here, now I know that days is here, and year is here. Now, so days cancels. There's 365 days in a year. We'll forget leap years. And so now I can do this. This is how you can answer the question to yourself. Hey, do I multiply or divide? So divided by 365. Now it's 1.775 times 10 to the negative 6. So let's do so if you got something like this, 1.8, let's just call it, times 10 to the negative 6, check it, that might be what your calculator says, or your calculator might say this, so it's going to be 1, 2, 3, 4, 5, 1, okay, so 1, 2, 3, 4, 5, 6. There's our negative 6. Good. So this is the answer, except you always write your unit down, which is years. So here's the answer. So do you see how it was the exact same thing every time? You know, what you're given times the fraction equals what you've been given times your fraction equals new unit. Take that times your fraction equals new unit. Da, da, da. So this is, I mean, this is more than you'll do in chemistry. Now, this was 4 conversions. In chemistry in January, which is, a lot of students always say it's the most confusing unit of the year, it's just 3 conversions. We'll spend 2 weeks on it, but honestly, it's just 3 conversions. So if you followed this process, there's an A coming for you in January, right? And if you don't quite get it yet, it's worth studying, because then when January comes, it won't be so confusing. That's why I'm trying to teach it to you now, so that you can get smooth and with the whole process. So when the chemistry comes at you, you can just deal with the chemistry, not the math. And honestly, if you can do this plus manipulating formulas, that's 95% of the math that you'll need all year. So that is it. I have one final thing for pre-AP people. So if you are a regular chemistry person, this will be kind of confusing, so you don't need to worry about it. But for all y'all pre-AP people, let's talk significant figures. So let's clear it, and actually let's not clear it. Let's just deal with it right here. We have numbers. So the question is, hey, I see a 1 here. Why are you going with 2 digits here? Shouldn't that be 0.9? And you have a 1 here. Shouldn't this be 0.02? And there's a 1 here. What's significant? So the quick and easy answer to this is these conversion factors, where we say that 1 week equals 7 days. Every conversion factor. This is just an example, but every one of these fractions that you're going to create, these are viewed as exact, meaning they will never impact your significant digits. So this simplifies things a lot, meaning you will only look at what you are given to figure out how many significant digits your answer should have. This is 56, that's 2 significant digits, 2 significant digits, 2 significant digits. Here I should have stopped at 2, tisk, 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 but I wasn't doing it then. But so that makes it easy. Just look at how many sig figs are in your what you're given. That's how many sig figs your answer should have. Don't worry about these fractions ever. That's it. Any questions, comments? Please let me know. This is very much worth your time to get down quickly. I promise you. See if I have another slide. I don't think so.